Go to Year 10. Here's a video that goes over quite a long question from the Graphs Practice JAF. I really like it because it links a whole lot of ideas about linear graphs together, but it starts off at unistructural level and it gets up to relational level. So if you're still working on the unistructural skills, watch the video, but just don't expect that it's going to feel very comfortable by the time you get to the end. Right, so we're going to start by just reading through the whole thing. We've got two lines here. We've got a red line, line B, and a blue line A. We have to start out by, not surprisingly, finding the gradient of the line. So we're going to use the change in y over the change in x, and we're going to use two blobby points. Then we have to use those gradients to write down the equations of the graphs. So I'd say that both of those are unistructural for Year 10. Next we have to see whether a particular point is on either line. So to do this, we're going to take the equations that we got in here, and we're going to substitute this x value into those equations and see what the y value is, right? So we're going to say if x is 27, which would be all the way out here, what would the y value be? And we're not going to do that by using a ruler and drawing it. We're going to do it by using algebra in our brains. Okay, next we have to give the equation of a line parallel to line B. That's actually a really easy question chucked in there. And lastly, the harder problem is to say we've got a line that goes through these 2 points, 6, 1 and negative 1, negative 1. So 6, 1 is here, and negative 1 is here. And then we have to figure out whether this point is also on this line. So hopefully what you'll try to do there is to find the equation of the line that goes through those 2 points. Okay, so let's make a start. How do I find the gradients of these lines? Well, we look for a couple of blobby points. So for line A, the blobby points that I'm going to use are this one here and this one here. And I'm going to draw on my triangle. I'm going out 2 and I'm going up 1. So the gradient is going to be the change in y, 1, over the change in x. I can't simplify that anymore. I'm going to find the equation of line A while I'm here because it's so easy to do. Remember that we write the equation of a straight line in this form. We know the gradient. We have to find the y-intercept. Here it is here. So its value here is 2, right? Nothing to do with this 2, just a coincidence. So this line has got equation y equals 1/2 x plus 2. Now let's have a look at the red line. Well, I'm going to use these two blobby points. You can use any blobby points, right? It doesn't matter, but I find these very easy to do. Let's just get rid of the mess from the blue line. So draw the triangle in. Remember, we go out first in this direction. So I've gone out 2, and then I've gone down 3. So the gradient is negative 3 over 2. What's the equation of the line going to be? Well, this point here is at negative 3 on the y-axis. So my equation will be y equals negative 3 over 2x, take away 3. So that's the first two questions done. Let's see what we need to do next. Okay, so is this point 27 and 15.5 on either of the lines? And we have to explain. So the first line, let's have a look. It might be on line A, right? Because we can see that this is going off in this direction and this line is going up here. This point is somewhere out here. But we can be pretty sure straight away that it's not going to be on line B, right? Because line B, for positive values out here, is going to be all the way down there. But I'm going to show both of these using algebra. But I kind of know what answer I might be going to get before I start. So the first line, line A, has equation, what did we get on the page before? Let's see. 1/2 x plus 2. So what we have to ask is when x equals 27, what's the y coordinate? So y is equal to 1/2 times 27 plus 2, which is 13.5 plus 2, or 15.5. So yes, 27 15.5 is on line A. Now we're going to do the same thing for line B. So line B had equation y equals negative 3 over 2x minus 3. I'll just check that's right. Yep. Okay, so substituting in, when x is equal to negative 27, what do we get? Well, we get 3 over 2 times 27, take away 3. Remember, it's fine to use your calculator, but lots of you won't have to. So this is negative, what do we get? I think we get negative 41.5. Is that right? That's not right. 81 divided by 2. Nope. 40.5 minus 3. I'm sure someone's going to leave me a comment if that's wrong. So there we are. We get a y value of negative 43.5, which is not equal to 15.5. So the point is not on the line. So again, we're using this very powerful idea of substituting into an equation. Right, next one's easy. Give the equation of a line parallel to line B. So parallel lines have the same gradient. What was line B? Well, line B was negative 3 over, y was negative 3 over 2x minus 3. So you can give an infinite number of answers here, but they have to have the same gradient. So you might be wanting to be concise, and then you could just write this, right? So this line is parallel. It's a special one because it goes through the origin, right? But it would have the same slope. You don't have to draw it, but we could draw it just for fun. There. Whoosh. Okay. Or we could do y equals negative 3 over 2x plus 5. And that would have the same slope, and it would go through there. All right, let's get on to this last question. So a line passes through these 2 points that we're given. And we're asked if another point is also on this line. So there are several steps here. To write the equation of a line, we need to know the gradient, and we need to know the y-intercept. And then once we've got the equation, we can substitute in x is 15 and see if 3.5 is the y-coordinate. The first thing to do here is to get m, the gradient. So m is equal to the change in x, sorry, the change in y. It's probably a fireable offence for a maths teacher. The change in y divided by the change in x. And we can do that in two ways. If you want to draw the graph, you can. Look, there's negative 1, and there's 6, 1. So what is going on with my rise and my run? Well, we can draw the triangle in, badly, but there it goes, and then we've got there. Let's get rid of that ruler. So the change in y here is up 2, and the change in x is out 7. So let's have a look at how I can do that without drawing the graph. Well, we've got the coordinates of the points. The points are 6, 1 and negative 1, negative 1. So what was my change in y? Well, it was this value minus this value. 1 take away negative 1. And what was my change in x? Well, it was this value take away this value. 6 minus negative 1. And that's 2 over 7. Okay, so two ways to do that. But we're not finished yet because we haven't found the y-intercept. So we know that this line has got a gradient of 2/7. So let's give ourselves back some space. Now this next bit we can't really do from the graph. Sometimes we can if we've got easy numbers, but in this case we're going to have to use the method of substituting in a point. So we've got 2 points we can choose from. We know that negative 1, negative 1 is on the line. So that means that when x is negative 1, y is also negative 1. Now that's just a coincidence, right? So this y value is what I'm putting in here. So I've got this simple equation to solve. So let's work this out. We've got negative 1 is equal to negative 2/7 plus c. So c must equal negative 5/7. Okay, so if you need to do that a bit slower, we could add 2/7 to both sides. So we get negative 1 plus 2/7 is equal to negative 2/7 plus 2/7 plus c. And these simplify away. So we've got our equation of our line. The equation of this line is y equals 2/7 x minus 5/7. Right, now what? Well, we weren't asked for the equation of the line. We were asked to do something with it. We have to say if this point here is also on the line. So we've got to substitute in the x value, 15, and see what y value comes out. So the line is y equals 2/7 x minus 5/7. So when x is 15, what's y? Y is equal to 2/7 times 15 minus 5/7. So y equals 30/7 minus 5/7, and 25/7. Now that equals 3 4/7, which is very close to 3.5, but not equal. Now if we go over to GeoGebra briefly, we'll see just how close it is. So that the point is not on line. So point not on line. There we go. Let's have a look at just how close it is though. Where's GeoGebra gone? Here it is. Okay, so I whipped this up before I made the video. The black line is the line with the equation. I wonder if I can show you. Yeah, so that's the line we just found, 2/7 x minus 5/7. And that blue blob sitting just underneath is the point 15, 3.5. Okay, so that's how you would show whether a point was on the line or not. Thanks for watching. There were quite a lot of linked up skills in this question. If you need more practice at individual ones, the Beta and Gamma textbooks are great, and so are some of the Education Perfect modules.